and digital vehicle development requires a product, including all its individual components, to be described precisely and effectively in terms of their functional mode of operation. EXOKNOX is a data management system specifically designed for this purpose, and it covers the entire process chain, starting with functional requirements management over order delivery management to traceable data usage. You would like to know how this system works exactly, so Michael Baumann is here today. He's a product manager and managing director at EXOKNOX, and he has all the answers. Please welcome him with a warm applause. Welcome, Mr. Baumann.
Thank you very much for the introduction. Yes, today I would like to talk about data management. Maybe just a brief introduction, since we are a mid-sized company, and I assume that most of you won't know us. I'm today here with my colleague, Dr. Hans-Dirk Walter. We are directly next to the stage at our booth. We are a company of about 60 people, all software engineers, or a software development company, mainly consisting of software development engineers, and we have 4 offices distributed all over the world. The headquarters is in Basel, Switzerland. We have 2 offices in Germany as well, and 1 in India. Okay, data engineering solutions. That are our automotive products, the data management systems I would like to talk about today. And in one sentence, EXOKNOX is a family of data management solutions that make the development of complex mechatronic systems that can be entire vehicles, engines, but also aeroplanes, wind turbines, and so on, more efficient and traceable, especially, which is also part of that talk today. Okay, so it's clear I'm talking about R&D tools. We don't provide any solutions which are directly in the car and end users come into touch with, that are R&D tools. We provide the whole stack from front end to business layer up to the server side, also services. And the most important message at that point is that we are a provider of solutions, but the data always remains at our customers. I think a company like, for example, VW, for that company, it's important that the data stays inside. Okay, why could data management be interesting at all? Sounds a little bit boring maybe, but we somehow have a mission. We would like to free engineers from a burden and support them to do their actual job, which is doing engineering, creating a majority of products. And there we identified 4 categories that contribute to the data management point. One is efficiency. From our own experience, when being when working in former times within the automotive industry as engineers, for example, in my case, I was a simulation engineer doing multi-body simulations and finite element analysis. I wasted a lot of time obtaining, comparing, transforming data, and I always wish to have a data management solution for that specific domain I'm talking about today. The slide after the next slide will show some details about that. Then quality, automated quality checks are well known. For instance, for geometrical product data management systems, but not for all other domains like functional data I'm talking today about. And what functional data exactly is, I will show you on the next slide after the next. So quality checks can be performed automatically, but as I said, not in every domain. Then it becomes interesting. Creating knowledge is also a category where data management systems contribute to. We are aware that very often there are different silos existing, and getting all the data together is a real effort, or sometimes not even possible, since the data depends massively on on well-structured metadata. That's a prerequisite, and we invest a lot of effort on good metadata in order to break down silos. And then traceability, that becomes very important in future, since when thinking about digital certifications, digital releases, all the entire data chain that made up the simulation, for example, is very important. And their functional data management is somehow a core functionality that is needed. We see that also in working groups we are active in, and it's an issue that will be important, as I said, in future, and there will be a focus on. So that's the main slide here. I think I need to explain it a little bit. In the middle, in the center, you see a product. Here, in that case, a car. On the left side, that should be a real car. On the right side, here, that is a simulation model. And if an engineer wants to describe that car, wants to set it up, wants to assemble it, different information is needed. That information is that green block here. The very basis are functional data for us, since functional data are curves, characteristic of single components, of systems, of subsystems, and all of these together make up the whole behavior, the entire behavior of the whole product. Then ECU code is necessary. Functional data is also part of ECU code. Think about engine characteristics, for instance. And then geometry. Geometry comes into the play, and of course geometry data coming from CAD systems is needed. In reality, real parts, geometry related data like joining technology, materials information, material models for simulations, and then a product structure. And if all this information is available, a product can be assembled in real world and also in the digital world for simulation. Okay. Now, when that product is available, an engineer wants to do something with it, and he applies maneuvers to it or load cases. He drives over tracks, digital or in the real world, and creates tons of result data that needs to be managed. And our products are exactly here, when a product for managing functional data. And spoil a little bit. Before EXOKNOX, no commercial functional data management system was available. And at the other end, when dealing with tons of result data, we have Lyzium. For us, as mentioned previously, the functional data are the absolute basic when doing any engineering, because think about when being a student, for instance, an engineering student, he can calculate some basic fuel consumption when having some efficiency values, drag coefficient, projected area, and engine characteristics, and that's all he needs. It's on a piece of paper. He doesn't need a computer at all. So that's the absolute basic. Okay. We are often asked how simulation data management, for instance, fit into that picture, and that is orthogonal to all of that special systems that provide special data from some special domains like geometry or even functional data. And a simulation takes data out of that EXOKNOX data pool. Because of that, we're able to pass all the traceability information from our data management world into the simulation, which then will be important when thinking about digital certification in future. At the other end, the result data can also be complex because a simulation performed today maybe needs to be compared to a real test measurement performed in 2 years, and it's very, very difficult to fit these data together, because the simulation data will be stored in a simulation data management system for sure, and the test data in a test data management system, and it's not that easy to identify in 2 years to which data the measured data will fit in terms of looking at the simulated data that has been generated today. So that's that massive structured metadata approach that I mentioned earlier that comes into play at that point. Well, and with our products, you see that at the right side, we form a bracket over all the central product development process an engineer or an engineering community performs. Well, and we're often asked whether that isn't already existing, and the answer is no. As I previously mentioned, with EXOKNOX Hub, that is the system for functional data management at the very basis, filled a white spot somehow. It wasn't available before. Maybe some in-house solutions, but no commercial system that also has some other specialities like supplier integration for getting data from external suppliers as well. Lyzium also follows some new approaches in terms of combining big data cluster, the big data management cluster, with an structured metadata approach, as I mentioned earlier, and all that on the basis of standards. So we have no proprietary metadata. These are standardized, and so there's no lock-in effect when using our products, which might be important as well. Well, at the end, I would like to take a look at some use cases. Here are use cases for EXOKNOX Hub and Free, the functional data management system. Due to the fact that the remaining time is short, I will skip the first two use cases, but for my opinion, they're interesting. It's functional requirements management and supplier integration, which contribute to a closed process chain for functional product development that we implemented. I would like to focus now on the third one. That's the automated parameterization of multi-body simulation models, where we use the fact that we have all the data together in one system, and we can automate by an internal Python scripting interface, Python scripting functionality, the transformation of measured data, of actual data, to the data rheological models of functional components normally require. And by doing so, at the moment, we were able in a real customer project to save 75% of time, which was a great success. And the mid-term goal is to make a one-click solution out of it. And I know that that worked very well since I come out of that domain initially. I worked weeks for parameterizing complex MBA simulation models. and that could be broke down to maybe minutes or hours, which would be amazing. Okay, another use case. Now, when looking at Lyzium, I also skip that data integration use case here as well, because I mentioned it earlier. That's combining different measurements or data from different silos. Here in that use case number one, we had a scenario, a data logger scenario, where petabytes of data were measured in an autonomous driving scenario, and there we are able to perform really fast analysis due to the fact that we work with function shipping, that we ship the analysis functions in our system to the mass data, which is very performant, and the mass data doesn't need to be moved after once storing it anymore, which is also somehow new. And the last one, I think time is over. Combining EXOKNOX FDM and the Lyzium result data management could give some really amazing insights, because in a project we examine the statistical parameters of all the functional data, which is the basis, for example, for performing design of experiment tests. And that information previously was not available normally. Because of that, that's an amazing use case, in my opinion, as well. Well, and as mentioned, time is over. I'm at the end. I try to give you a brief insight into the amazing world of data management, which really can be amazing. Thank you for your attention. And if you have questions, as I mentioned, I'm available at the booth directly next to the stage.